Here, we are going to look at velocity or speed time graphs. These graphs look at the change of velocity or speed over time. It will be useful if you first go through the videos on distance and displacement time graphs before starting this series. Take a look at the simple velocity time graph. Note, on the x-axis we have the time measured in seconds, and on the y-axis we have the velocity measured in meters per second. If this was a speed time graph, then on the x-axis we would again have the time measured in seconds, and on the y-axis we would have the speed measured in meters per second. Now let us add values to our graph. The point A to B shows an increase in velocity of 18 meters per second. The gradient or steepness of this line is the same as this change in velocity divided by the time taken for this change, which is 10 seconds. Velocity divided by time is the rate of change of velocity of the object, which is called acceleration. We can find the acceleration of an object at any point on a velocity or speed time graph by finding the gradient at that point. A straight line will show a constant acceleration. A change in velocity of 18 meters per second divided by a change in time of 10 seconds gives us an acceleration of 1.8 meters per second per second. Now let us calculate the acceleration between point B and C and point C and D. The acceleration between point B and C is fairly easy. As there is no change in velocity, the object is moving with a constant speed. Therefore, it has no acceleration. Note, a horizontal line on a velocity or speed time graph means the object is still moving but at a constant speed. The object is still covering distance but at a constant rate. Though a horizontal line on displacement or distance time graph shows an object at rest. The acceleration between C and D is found using the gradient. The change in velocity is again 18 meters per second, but because it is decreasing, we must use negative 18 meters per second. This occurs over 20 seconds, so negative 18 divided by 20 equals negative 0.9 meters per second per second. We can either say acceleration is negative 0.9 meters per second, or that it is decelerating at 0.9 meters per second, removing the negative. Now consider you're given velocity time graph of two objects. The different options look like this. The white line shows a faster acceleration, while the blue line represents a slower acceleration because it is steeper. The white line has a higher rise and lower run compared to the blue line, so it is reaching each velocity in less time. If we move further for the blue line, no acceleration is happening and then decelerating, meaning it's slowing down. It's coming from 8 meters per second velocity to 0 meters per second. Just to recap, the gradient of speed or velocity time graph represents acceleration. If object moves with uniform acceleration, we get a straight line. When the line is sloped upwards, the gradient is positive. The object is accelerating and its speed is increasing. If the line is sloped downwards, the gradient is negative. The object is decelerating and its speed is decreasing. If the line is parallel to x-axis, then the gradient is zero. The object is moving at constant speed, therefore zero acceleration. Now try a practice problem. What is the acceleration of the object between point A and point B? The change in speed is 25 minus 5, which equals 20 meters per second. The change in time is 6 minus 2 equals 4 seconds. So the acceleration is 20 meters per second over 4 seconds, which equals 5 meters per second per second. Is the acceleration large, small, or zero in the following speed time graphs? Also, is it positive or negative? So that's how speed, velocity, and acceleration are related and can be calculated.